Today, we will be discussing the science behind the sports that you love, and in particular, projectile motion. When a ball is thrown, this is an example of what scientists call projectile motion. Projectile motion occurs when an object travels in the air along a curved path, and the only two things acting on the object are 1. Gravity, and 2. Acceleration. Now, what is gravity, you might ask? Gravity is a force that attracts everything to the center of the earth. As physicist Isaac Newton discovered, it is the reason why apples fall from apple trees. Now, what is acceleration? Acceleration is the rate at which the speed changes. When you stop pedaling on a bike, you have less acceleration because you are slowing down. When you start a race, you have more acceleration because you are speeding up. Now that we have defined some basic terms, let's think about holding a ball in your hand. Now, there are many ways that you may throw it. When thrown straight up, the ball goes only up, then back down. This is because there was no horizontal acceleration applied, and so gravity just did its job and pulled the ball downwards. When thrown horizontally, the ball travels side to side, but only falls to the ground. This is because of the horizontal acceleration and gravity. We throw it again, straight forward, and we see that the ball just hits the ground, not going very far. This is called the horizontal direction. In most of your favorite sports, we want the ball to go as far as possible. There must be some compromise between the two in order to maximize the distance we can throw. In order for this to happen, we can throw the ball at an angle, giving it both vertical and horizontal speed. Here we have a simulation of a ball being thrown, but the person has been replaced by a cannon. In real life, lots of things affect the ball, like wind, how hard you throw it, and air resistance. But in the simulation, all of these things are kept the same between the throws. When we see our friend throw the ball straight up, that was the highest the ball could reach. And when he threw it straight out, that was the furthest the ball could reach. To reach our goal of throwing the ball the furthest, we want a combination of height and distance. This sweet spot for the ball to be thrown in exactly in the middle of straight up and straight out. If you throw a ball at the same angle many times in a row with the same speed, it will land on the exact same spot. That's why basketball players are able to score so many times. Because they practice so much, they know exactly how fast the ball needs to go and the angle they need to throw it at to score from different positions in the basketball court. The same holds true for many of your other favorite sports, like baseball, softball, or football. Because the simulation is so consistent, we can calculate exactly where the ball is going to land. From our calculations, we know the ball is going to land at 10 feet. These are the basics of projectile motion. Perhaps one of the more famous examples of projectile motion comes from rockets, such as the kind launched into space. They generate huge amounts of energy in order to lift off the ground and launch itself off the planet. At the same time, they work to overcome the gravity that wants to pull them back down to Earth. Because of this, they may appear to be launched vertically, but that's because rockets are launched at a slight angle with respect to the ground, and their flight paths are huge. By comparison, the ball in our example was thrown 10 feet, while the distance from the ground to the atmosphere is roughly 327,360 feet. That's 62 miles. Math and physics are constantly present in the world around us. From throwing a basketball to driving a car to playing video games, we can apply the concepts we learn in STEM classes to understand why objects move and change shape. Everything in the world has an explanation, which is one of the most exciting things about being a STEM student. Engineers are always searching for new ways to improve things and solve real-world problems. We encourage you to ask your science teachers for more information on what it truly means to be involved in the STEM field. If you are interested in learning more about our chapter, you can check it out on the website shown here. Now, the next time you throw a ball, think about the math and physics behind it. Simply everyday activities have complex explanations, and you might just impress your friends if you can throw your ball the farthest out of all of them. We hope you learned something new today. Thanks for listening.